Today we're talking about a linear relationship and specifically about whether that relationship is proportional or non-proportional. Now, the big idea of this is that you have a ratio. There's a ratio between the values of x and y. So we're going to first look at some graphs. The general rule is when you see a linear function on a graph, you look at it and you see, well, first it has to be linear, but then you look to see if it contains the origin. If you have a linear, that is a line that goes through the origin or looks like it would go through the origin, then you're dealing with a proportional graph. Let's look at a few examples. In this first case, this is definitely a line. Actually, all four of these are examples of linear proportional graphs. Notice it is making a line and it goes through the origin. This one has a line that goes through the origin. Hopefully you remember that if it has arrows at the end of the function, it means that it goes on forever. This one, however, if you look at this one right here, notice it doesn't have arrows and it doesn't quite go through the origin, but it actually touches the origin. And in this case, what we're evaluating is, does it have the ordered pair 0, 0? And it does. So this would definitely check out. The last one here, we've got these, this is called a discrete linear function, which means the dots are disconnected. However, it is still a linear function because if I did draw a line and connect my dots here, it would indeed go through the origin. So there's four examples of what you're looking for when you look at a graph to see proportionality. Now let's look at a non-proportional graphs. Here are some non-examples. And again, we've got some key words here that I want to focus off of here where we're talking about non-linear graphs. That is non-line graphs. These are graphs that have curves or bends or fold upon itself. Or, and keyword here being or, it does not contain the origin. So it could be either one of these, where before we had an and situation. It had to be a line and either go through the origin or look like it would if the line continued. So let's compare, looking at our proportional graphs and our non-proportional graphs. And you can see off this first one here, my origin's over here. Yes, it does qualify as a straight line. It is a linear function, but it is not a proportional linear function. So this is not it because it does not go through the origin. If you look at our next one, hey, it goes through the origin. It actually looks like it has two lines. However, this bend right here, that means it is not a linear function. A linear function has no bends, no curves, and none of this nonsense that you see going on with this one. So this one qualified because it goes through the origin, but it's not linear. The next one, this one also goes through the origin, but it has those curves, and we don't like curves when we're talking about a proportional linear function. This next one, we have a scatter plot. Very organized scatter plot, right? Looks like a little heartbeat there. However, it is not linear. Notice that this one up here, we had these dots in a straight line. Even though they're not connected, it's still considered a linear function because they line up consistently. They have a constant rate of change. This, it goes up for a while, goes down, goes up, goes up, down, up, down. That is not a constant rate of change. And you know what constant rate of change is from what we learned earlier in the week. So that's how I want you to be able to differentiate. Just looking at a graph, you should be able to tell if it's proportional or non-proportional.